So guys, welcome back to the Health and Wellness Spot. I am Dr. Lewis, and today I want to make a simple video for each and every one of us to understand diabetes, how it comes to happen and what is diabetes in the first place. So some of us, when we talk about diabetes and sugar levels, we don't get it. Okay, when we talk about drugs that help us manage diabetes and how to avoid those drugs through diets, it happens like it's Greek, so most of us don't get it. So today I've decided to make a very short and precise video over diabetes, and I hope you guys enjoy it and get to learn better. So what is diabetes? Basically, diabetes is a sugar disorder, is a carbohydrate disorder where there is an increase in blood sugar levels. Now, this is just a diagrammatic or a schematic representation of the organs that are involved in control of blood sugar. So this is the bloodstream, and in blood, whether you've eaten carbohydrates or you've not eaten, whether you're fasting or you're not fasting, there's supposed to be a constant level or a certain level of glucose that is present in your bloodstream, and that runs from 4 to 5.5 millimoles per liter of glucose. So therefore this level is supposed to be maintained by all means. Now, whether you're eating or not eating, when you're eating, then this level will be maintained by the pancreas. When you're not eating, then this level will be maintained by the liver. So when you're eating, the pancreas will give you insulin to lower your blood sugar back to normal, even though insulin lowers it quite lower, and that's the reason why you get cravings all the time. However, when you're not eating, possibly when you're fasting, there is storage of glucose in the liver in form of glycogen. So now the liver starts to pump this glycogen, or breaks it into glucose and pumps it into your blood, so that the level that is supposed to be normal in your blood is maintained. Now, when you eat carbohydrates, what happens? You start breaking carbohydrates straight from your mouth into your stomach through an enzyme that is called salivary amylase. Now, this enzyme is found in the mouth and in the stomach. So you start breaking carbohydrates from the mouth slowly into the stomach. So now this food has come into the stomach, is still being broken down into the smallest or the simple sugar, which is glucose. So this is our major concern. So this glucose goes into the small intestine and it's absorbed. And when it's absorbed, it goes into the bloodstream. Okay? Now, in the bloodstream, remember we said we have a certain level that is supposed to be maintained. Now, since we are loading in glucose into the bloodstream, this level starts to rise. So we have hyperglycemia, an increase in blood glucose. Hyperglycemia is the same as diabetes. So a prolonged levels of glucose in the system, high levels of glucose for that matter, that is what we call diabetes. Now, this glucose level in the system is rising. The body instructs the pancreas to produce a hormone called insulin. So insulin now drops into the bloodstream to help you lower these increasing levels of blood glucose. And how does insulin lower these levels? Now, these three organs, the liver, fat cells, and the muscles, these three tissues are highly dependent on glucose for functioning. And therefore, insulin has its receptors on these three organs or these three tissues. Now, a receptor is possibly a channel that insulin will bind to help you open up the gates so that sugar goes into the muscle or the fat or the liver. Now, you realize I've drawn a receptor here and I've drawn a gate here. So remember, you have insulin to lower this glucose into your system. So insulin comes in, binds to these receptors on these tissues. Now, binding to these receptors happens to be like a key. So once it binds to these receptors, it opens up these gates. So this gets into, it opens up this gate so that glucose flows into these tissues through those gates. So insulin is very important in regulation of blood glucose because of this. Once it binds to the receptors, it opens up the gates, and these gates allow glucose to flow inside these tissues. Now, once glucose flows inside these tissues, then blood glucose level goes down. So that's how insulin possibly works to help you recover or lower your blood glucose levels. And that's also the reason why insulin is used in diabetes. Now, after this has gone into the liver, glucose is stored in the liver as glycogen. In fat cells, it's stored as triglycerides. Then in the muscle, it's also stored as either fat or glycogen. Now remember, these three are the storage reserves for glucose. Now when you stop eating carbohydrates, the pancreas has no role in controlling your blood sugar levels. Now the liver starts pumping glucose into the bloodstream because it's breaking down glycogen into glucose. Also the muscle does the same. And again, after you've exhausted this glycogen, the fat comes in. So you start breaking fat down to form triglycerides. And ketone bodies, sorry for that matter. Now, that's the reason why fat does not increase insulin levels. Why? Because fat does not release glucose. But remember, all these sources, be it fat, be it protein or carbohydrates, all can be broken down to give you glucose. However, fat is broken down mostly to give you ketone bodies, which we also said they're the best sources of energy for the brain and the body. So this is a source of a good energy source and fuel for the brain. And also this will help you to reduce your weight. So therefore, that means if you have high levels of insulin, then you will never burn fat, because insulin will keep on opening these channels and glucose will keep on going into the fat cells. So if you want to close this up so that glucose does not go into fat cells, then what you do, you're supposed to block this by fasting. Once you fast, then you block insulin from going into the cells, and you now produce a hormone called growth hormone. Now this growth hormone will encourage you to burn fat, and this burning fat will encourage you to lose weight and recover from insulin resistance. And therefore fasting is very important in this and in entire recovery from diabetes. Now diabetes is divided into two, type 1 and type 2. There's also a type 3, which is we'll handle later on. But type 1 is where somebody is either born with a dysfunctional pancreas, and therefore in the pancreas there are cells called beta cells. So these beta cells are the ones that produce this insulin. So if you have a dysfunctional pancreas, then you'll not have beta cells, then you'll not produce insulin, and therefore you'll not control blood sugar levels. They'll keep rising. Number 2, sometimes you can have an autoimmune disease that targets beta cells. So it clears these beta cells, and when it clears them, then again you don't produce insulin, and then again you cannot control your blood sugars. That is type 1. And therefore type 1 will only rely on external insulin. That's why they are given external insulin all through. Now, the other type is type 2 diabetes. Now, type 2 diabetes is where all your organs are functional, but it is on the receptors. So therefore, these receptors have been desensitized. And then if you desensitize these receptors, even though the pancreas is producing insulin, the insulin cannot attach itself on these tissues, and therefore glucose cannot be reduced in blood to go into these tissues. So that brings a problem. So type 2 is basically desensitization of these insulin receptors on the tissues that are supposed to take up glucose. Okay? Now, you realize type 2, you will either require external insulin, if at all, because the reason why you'll get into insulin is because if these ones are not functional, the receptors are not functional, blood glucose keeps going up, and the pancreas keeps on working harder to produce more insulin to clear this. But remember, it's producing insulin, but this insulin is not going into the tissues, and therefore the pancreas gets exhausted. Now that's when you require insulin, external insulin shots. Okay? Now, management of type 2 diabetes requires drugs like metformin, and metformin is from a group of drugs called biguanides. Now these drugs, their function is just to improve or to increase sensitization of insulin to these receptors. So they work at the receptor level to increase sensitivity of insulin to these receptors, so that insulin that is being produced can attach to this, open the gates, and then glucose flows in. That is one. Another group of drugs is called sulfonylureas. This is where you have the Noglux, and that's a trade name. So the generic name for Noglux is glibeniclamide. Okay? There is also other drugs called glipizide and gliclazide. All those are drugs or glimeprimide, something like that. So these are the drugs that work at the pancreas level. And at this pancreas level, their work is to increase the production of insulin. Okay? So if at all you have a dysfunctional pancreas, maybe it has been exhausted, and you have already, your receptors are desensitized, what we will make drug combinations that will activate the pancreas to produce insulin and also help sensitization of the receptors. And this is why this is the reason why there are so many drug combinations for diabetes. However, even with these drug combinations of diabetes cases are still on the rise. The question is why? And the answer is right here. These drugs are helping you to manage symptoms of diabetes, but they are not treating the cause of diabetes. They are not blocking you from eating carbohydrates and simple sugars. Okay? So the more you eat simple sugars, even with these drugs, you will still have a problem. And that's why some of these people who are diabetic, they still take these drugs and still head on for amputations and still lose their sight and still have kidney problems, because sugar is still coming in and therefore you're exhausting your pancreas. And even if you're taking these drugs, you're still taking it in. Number two, most of you have been told that taking diabetes drugs requires you to take them with food, specifically metformin. Now, if you're taking in carbohydrates and you're trying to solve carbohydrate intake by taking in metformin, you're doing zero work. So basically, the entire cycle of diabetes lies in the hands of simple sugars and carbohydrates intake. So if you reduce this through the dietary modifications, then therefore you will not require all these processes and you will not require these drugs. Okay? So basically that's the basis of diabetes. And if you have any question, possibly throw that question into our comment section. We will be able to answer every question regarding diabetes mellitus.